Hi, we were examining two ports. That's Turkish, but it is two ports. So we defined what two ports are, and we also define what port is. And then we found two port parameters. Finding two port parameters means finding the mathematical model of a two-port circuit or equivalent circuit of a two-port circuit, or mathematical model, I said, or the definition relation, isn't it? So they are all the same. So we have done this. Now the next step, we will be examining two-port circuit analysis by using two ports or mathematical models of the definition relation of two ports, how we can analyze this circuit which includes that two-port circuit in it. So like this. So we know the definition relation of this. So that is, let's say, Z parameters of this two-port circuit or definition relation. The next step is how we are going to use to analyze a circuit like that. While we are analyzing this circuit, we are dealing with only one of the element current and voltage, that is that ZL. L comes from load impedance, current and voltage. So we are dealing with only one element current and voltage. Why we need that? So we have done the similar thing. Also we explained in details in Thevenin equivalent circuit analysis. We found one of the element current and voltage, and transfer function we also found one of the element current and voltage, and that is the third one. But there are nuances for these three methods. So this is the most general one. Why it is the most general? Because the input of this two-port circuit can be any circuit. So these two represent the Thevenin equivalent of this any circuit. And the other port, which is the load port, could be connected to any impedance you can think of. Therefore, it is the most general one, and in this our aim is to find that V2 and I2. That is the first aim. On the other hand, if we can calculate the V1 and I1, that means input port variables, isn't that V1 and I1, V2 and I2, second port variables. So we do need the V1, I1 values as well. Why is that? We can figure out, in this case, the whole circuit, this circuit, power consumption, if you know that V1 and I1. Why we need the power consumption? Less the power consumption by this circuit is better, isn't it? So that means you are doing what you need by using a less amount of electrical power. That's why it is important. Now, first, what we are going to do, when a circuit like that given to you and the Z parameters are known, or definition relation of two port is known, then we can calculate V1 and I1, V2 and I2. This relation is not enough to do so. Why is that? Because there are four unknowns, two equations here. We've got to add new equations to that in order to find these unknowns that we do need to find. So let's move to open board and see it step by step. Here we are. That's our two-port circuit, and definition relation for this two-port circuit is V1 is equal Z11 I1 plus Z12 I2, and V2 is equal Z21 I1 plus Z22 I2. These are the Z parameters, definition relation of this circuit, isn't it? So this circuit model is this. And our unknowns are V1, I1, V2, I2. So there are 4 unknowns, 2 equations. We need to write 2 more. So we are going to write one of them from the left hand side part of this circuit and the second one from the second part. So for the first one, if I write the Kirchhoff voltage law equation, so let me clear this area to make it a bit. Okay. So if you consider this loop now and write the Kirchhoff voltage law equation for this loop, Zg times I1 gives me that voltage, isn't it? Zg I1 is that voltage plus V1 minus Vg. If I move that Vg to the right hand side, it becomes Vg here. This is Kirchhoff voltage law equation for this loop. So if you come to this side, since this V2 is the second port voltage, is also the voltage of this impedance, isn't it? That's V2. If this is V2, then according to passive sign convention, the current reference is going to be downwards, which is negative of this I2, isn't it? If you write this Kirchhoff current law equation for this node, you can figure that out. So that current here is equal IL, I2. So IL is equal I2, IL this is load current. Load current is equal minus I2. So if I write this V2 ZL times IL is equal minus I2, so it's going to be this one. So there is a negative sign in front of it. So if we consider now these 4 equations, we said these are unknowns. So what are knowns? So this is the Thevenin equivalent of the input circuit to our 2-port circuit. So that Vg and Zg are known. A load impedance also is given, so that means these are knowns. So we know Vg, Zg and ZL. Then from this we can calculate all these unknowns that we already set here. So how we have done this analysis? By using these Z parameters. Z parameters could be considered as definition relation of the 2-port circuit, or you might call it mathematical model of the 2-port circuit, or you might call it equivalent circuit. Of the 2-port circuit, make it 2-port circuit, which is this circuit. So the next frame, let's move now to Prezi one more. this a bit downward. So we just explained how we can calculate that I1, I2, I1 V1 and I2 V2. Now we are in here. These are some new terms that are used in electronics quite often. So we are going to make a relation between this terminology and the unknowns that we have found. So this unknowns here. So we have found that these unknowns. Therefore, we are going to show this relation, that electronic terminology. What is it? There are 6 characteristics that we are going to mention here. Input impedance, input admittance, output current, Thevenin equivalent for second port, so that means this circuit here. So 2-port circuit and this Thevenin equivalent circuit, Thevenin equivalent is this. So we are talking about Thevenin equivalent circuit for the second port is the one that I just mentioned here. Current gain I2 over I1, port voltage gain V2 over V1. This is in Turkish, but voltage gain V2 over VG is the voltage gain between those two voltages. So these terms are commonly used in electronics, so we've got to make a relation between the unknowns that we found here and these new characteristics. Some of them are important. Let's mention the gain is important, of course. Voltage gauge, current gauge, we can easily see that. And this input impedance, why it is important. If you want to have, let's say you design a circuit and this is your previous circuit and this is going to be the load of this circuit, isn't it? So what you wonder, the amount of power consumed by your circuit is critical. How are you going to find it? V1 times I1 determines this circuit power consumption. Less the power consumption that you design, your designed circuit, means better it is. Why is that? Because you are doing the same job by using less amount of power, electrical power, so that's quite reasonable. So in order to calculate that power, you need that impedance higher, isn't it? If this input impedance is high enough, so that means you're going to say that the power consumption is going to be less. Also, the impedance that you see from this second port, which is the second port ZTH value here, is also critical. You want to have that that impedance as small as possible. Why is that? Because that means most of the power goes to your load. Otherwise, you're going to lose some power in between, isn't it? Because if the Thevenin equivalent impedance is high, so in the Thevenin equivalent circuit, you're going to consume some energy, power. If you don't consume that energy and power, so that means you transfer that power to your load. So this impedance seen from this second port must be as small as possible. So the next step, so we said now these are the terminology that will be used in electronics letters, in electronics courses. And now the second frame tells us these characteristics, how we can write these characteristics in terms of these 2-port circuit parameters, mathematical model parameters. So it is shown here. If you've got Z parameters, the 6 characteristics that we mentioned here can be calculated by using the Z parameters as seen here. So you could, once you know the Z parameters of this two-port circuit, you can directly write 6 characteristics by using the Z parameters of this two-port circuit. You could use that formula. You don't have to do these operations and find out all the element V1 and I1, V1, I1, V2, I2 port electrical quantities. If you do this if you calculate these quantities, then you can find all these characteristics. Now we are saying that you can find these characteristics directly by using the Z parameters. So you could use this table. It is also available here, a table. If you know the Y parameters of this two-port circuit, the 6 parameters that we mentioned already can be calculated by using the Y parameters in here. It is also true how to calculate the 6 parameters by using the transmission parameters, A and B parameters, or by using the hybrid parameters. You can calculate all the 6 characteristics we just mentioned here. The last one is just an example for you to practice. These are the numerical values included two-port circuit. So then you can find all the 6 parameters that we mentioned here and check it whether it is true or not by using this result given here. Also, you are free to choose the formulas in this frame to get that result easily. So that is end of this video then. Let me stop here.